Okay, so now remember, in this semester of pre-cal, whenever we take the square root of an expression or a number, we have to consider the plus or minus. Remember, some of y'all got points taken off on your tests that I turned into you yesterday because you forgot to place the plus or minus in your x-intercepts or your y-intercepts or whatever we were working with. You need to know when to distinguish or in other words, when to place the plus or minus and when not to. Remember, I said when we discuss distance, when you take the square root of something, you technically do have that plus or minus, but we know that distance is never negative. That's why we don't include it in there. Same thing with radius. Whenever we had to complete the square, and you have it set into the standard form of a circle, that right-hand side, the number is r squared, and in order for you to get r, you take the square root of it, and technically it's plus or minus, but we know that a radius cannot be negative, so that's why we exclude the plus or minus in that case. So in this case, when we root both sides, we get y is equal to plus or minus square root of 1 plus x. Now this is very interesting because you can definitely see that whenever you plug in a value for x, let's plug in 3. If x is 3, I have 1 plus 3, which is 4, and the square root of 4 is plus or minus 2. Now remember, the definition of a function is that for every x, there is exactly one y value. And in this case, we don't have only one y value. We actually have two y values. We have one that's a positive value for y and one that's a negative value for y. So again, here in this case, we have two y's for each x that we plug in. Therefore, this equation right here does not represent a function. So b is not a function. So please keep in mind about that one. Okay, so now let's continue with some more examples. Now we've discussed whether something is a function or not. Now let's discuss domain and range. Now this is probably the most traditional way that you've most likely been introduced to domain and range. You have a certain function. In this case, I will call it function f, which consists of a set of ordered pairs. Okay, so if I were to ask you what the domain is of this function, that's very easy because you know that the definition of domain is the set of x values. So what you do is you take each of these x values from the set and just line them up. I technically would like you to line them up from least to greatest. So in this case, it would be our domain is -3, -1, 0, 2, and 4. Okay, so that is the domain for that one. Now let's take a look at this one. It says g of x is equal to 1 over x plus 5. Now that's a very interesting equation. First of all, we should kind of be able to figure out what it is. Basically, it's a polynomial because let's agree that 1 is some kind of polynomial. Technically, it's a constant over another polynomial, and in this case, this polynomial happens to be a linear function. So, what do we call a polynomial over a polynomial that's in fraction format? We call it a rational expression. Okay, so for this one, it's very interesting because basically, if you were to graph this in your calculator, you can tell graphically what your domain is if you're really good at looking at a picture, or just by glancing at this, you need to consider the most important thing about this. The most important thing whenever we had rational expressions was that your denominator, in other words, your bottom or your polynomial that's in the denominator, cannot be equal to 0. So in other words, what you do ideally is you take this x plus 5 and you set it equal to 0 and you solve for x. Whatever you get for x, that is the value that it cannot be. Because if you were to plug in that value that you get for x into the denominator, you would get a division by 0. So let's just look at it here. We're just going to eyeball it because this one is a very simple one. Think of a value that you can plug into x that when you add 5 to it, you will get a 0. Okay, that's very simple. -5, right? Okay, so if you were to plug in -5 and you add 5 to it, you get 0. So really, what happens is that the way that I notate my domain is that it's all real numbers. It's the set of all real numbers. However, I have to add my stipulation to it. I have to say that x cannot equal -5. It can be any number in the real number system. However, it cannot be -5. Because if I were to place that -5 into the denominator, it would give me a division by 0. Okay, so that's very important. So let's look at this graphically because I want to show you how it is graphically. Let me see. Okay, so I have a calculator on here, and I may have to use another one. So let's just use an online graphing calculator. All right, let's see if I can find the best one. Okay, so here we go. Let's use this one. It says that I can graph the equation on here. So let's graph 1 over x plus 5. Okay, perfect. So let's take a look at what's going on in this case. If you look at this picture, remember, domain is anything that's going on in the x-axis. So if you look at it, if you look at the x-axis, your graph on this side is continuously going towards the left-hand side, which we will call -infinity. It's getting as close as it can to the x-axis, but it's really not touching it. It's going to get super close to it. Now, on the right-hand side, so in other words, this picture, look at what's happening. It's going towards your x-axis, but it continuously goes towards your right. In other words, let's call that positive infinity. So what's happening? It's going towards positive infinity. It's going towards negative infinity. But you also notice some sort of gap in this section right here. And if you look at it, that gap is what we technically call your asymptote. Now, I haven't covered vertical and horizontal asymptotes. That's something that should have been covered in Algebra 2. If you haven't covered it, I briefly touch on it, probably in a couple of weeks. But right here, that asymptote is your boundary. In other words, it's never going to touch it. Because what happens if you were to touch -5? You get division by 0. So that's exactly what happens. So in other words, your domain basically is from -infinity up to -5. We're not including -5, so it's not inclusive. And then we go from -5, we're not including -5, all the way to positive infinity. So in other words, basically, in short, all real numbers except -5. Okay, so let's continue with the next one. Let's continue with C. Now, this one's a different one, but it's the same thing. Now, this one is involving radical expressions. So here in this case, we have the radical, or the square root of 4 minus x squared. Now, remember, we had a stipulation with radical expressions. And the stipulation was that anything that was underneath it had to be greater than or equal to 0, because if you were to get a negative value inside the square root, again, at the moment, you can't take the root of a negative number, so you wouldn't be able to continue with this problem. So let's go ahead and do this by hand first, because I know that I've skipped some steps in the PowerPoint slide, so I will do it by hand first. So I will open up, let's open up Paint and do that by hand. Okay, so I have now again, I'm just going to take what's underneath the square root, so 4 minus x squared. And remember, I'm going to apply the stipulation. The stipulation is that it has to be greater than or equal to 0. Now again, there's different ways to solve this one. What I would do is, I noticed that this is a difference of squares, so I would go ahead and just factor it. Now remember, a difference of squares is basically telling you that it's going to be the same thing, except for one is plus and one is minus. So I will have a 2 and a 2, a plus and a minus, and then how do I get x squared? An x and an x. Okay, so what happens? You have to take each one and set it greater than or equal to 0. Okay, so we have, let's take the first one, 2 plus x, and we're going to say it's greater than or equal to 0. So we have, if we move this 2 to the other side, which at the moment is positive, if I move it to the other side, I get x is greater than or equal to negative 2. Okay, here, if I take this one and I say 2 minus x is greater than or equal to 0, if I were to move that 2 to the other side, I get negative x is greater than or equal to 0. I'm sorry, negative 2. But remember, I'm looking for x. So basically, I have to divide by negative 1. So if I were to divide by negative 1 on both sides, now let's go back to Algebra 1 and inequalities, which you should have learned. Whenever you divide by a negative value, what do you do with the inequality? You have to flip it. So this becomes x is less than or equal to positive 2. Okay? So basically, your x values are that it has to be greater than negative 2, but it has to be positive, less than or equal to positive 2. So there's different ways to express that. One way is in inequality form, so it's negative 2 is less than or equal to x, but x is also less than or equal to positive 2. And another way is the college way. This inequality right here, less than or equal to, anything that's less than or equal to traditionally in algebra represents a solid line. Well, in college algebra or anything past college level, we use brackets to represent solid or inclusive, basically. So basically, this is the same thing as saying from negative 2, we use brackets, comma, to positive 2. Don't think of it as an ordered pair because it's not. This is a notation for writing domain and range. So brackets. Okay? Alright, so again, if you need to go back to the video, let the substitute know, and then he or she can pause it, go back, rewind, whatever that needs to be done for you to get the notes. So let me go over what I have in the PowerPoint slide up here. So I have, for C, again, you have to set 4 minus x squared greater than or equal to 0. Then, of course, you're going to have to factor it and find the, I call it CNs from algebra, from calculus critical numbers to test each interval. So basically, just factor and then solve for x, and you get that it's from negative 2 to positive 2. Okay, so that is the C part. Okay, let's go over two more examples. Well, not two more. It looks like we have quite a few, which should be able to help you on your tests or on your homework. So before I do that, let me go over